Yes, perfect.
You know, talking to Lisa, she said the best part is coming this time. Last time was just hard work.
Well, this is the interesting part.
Yeah.
It
So
can either
let's see.
be very interesting or sort of go on the scrap heap of try again.
Okay, let's see which way we go.
Okay. All right. So tonight's presentation is a continuation of last week, but looking at it from a different angle. And what we're looking at is sort of field interactions within the plant tissue. And I'm using the method of circular chromatography to do that. So I'll go through the process. So last week we had a look at the benefits of using the GANs and how it increased the nutritional value of the plant and also the shelf life. And so I was trying to find out and work on methods to try and show another way visually of the effects of using the GANs on the produce, because as we said, you know, if you pick up one apple or one banana that's been grown with the GANs and the other one that hasn't, on the surface they might look the same, but internally there's a big difference. So I had come across the circular chromatography, which was invented by Einfried Pfeiffer. He'd originally developed this method to evaluate the life in soils, and this was almost 80, 90 years ago. So it was a quick way to determine the health of any soils. So in the soils, they were assessing for the humus, the minerals, the microbiology, and more. And most of the work done with this analysis was on soils. Very little was done on plant material. And so this analysis is not an exact science, but rather an interpretation by the observer. So the purpose of the chromatography was to allow the separation of the different organic components that make up the plant matter or the soil. And it looks at the separation of the layers from the center to the outside on a filter paper, and it's using the silver nitrate. So I'll go through the process that we had done. But what we had looked at was comparing the Daikon radish, which we had shown last week, that had been grown with the plasma. And the only way we could do a comparison was to purchase some Daikon radish from another grower. And then we had also done some of these chromatographies on the Daikon radish, which we had just grown in the environment without any addition of GANs. And then I'd done another set of experiments on our cos lettuce, which was grown with the plasma. And then again, I purchased another cos lettuce from the shops just as a comparison, just to create a visual comparison. So those were the three experiments that we had done. Now, the way we prepared was we needed 0.5 grams of silver nitrate mixed in 100 mils of distilled water. Now, with that solution, we had used a circular filter paper, and then we just cut a little square of it and rolled it up, so that became a little wick. And then we just created a little hole in the center of the filter paper, and then put the wick through, and then we just let this sit in the solution of silver nitrate, and through the capillary action, the liquid gets absorbed, and we did it to a radius of 4 centimeters. We then removed the wick and then allowed the paper to dry. So that was the basis preparation for the filter paper. Now we got to look at processing the plant material, and with that, we used 0.5 gram of caustic, NaOH, in 500 mils of distilled water. And we mixed that with 50 grams of the plant material. And then we just use a stick blender to mix it all up. And the picture shows the nice green mix after mixing. And then we let that solution with the caustic sit for 1 hour. Now we then start creating the chromos. So we then take that solution. So we've got our filter paper, which has been impregnated with a silver nitrate. And then we put a new wick in. And then we basically pour some of that solution, plant solution, and we allow that to wick up into the filter paper, as shown there on that picture. And you just allow it to wick, and it can take quite long. Some of them took 30 minutes to reach sort of that 4 centimeter radius. So you need a lot of patience for this one. And then what we do is, once that's over, we remove the wick, and then you hang that filter paper up in sort of indirect sunlight and allow it to dry. And this can take several days, and it's quite fascinating to watch how the images change over this time as it's been exposed to the light. And then your chromos are basically ready for analysis and interpretation. So, as I said, there's a lot of information on the chromos and using on the soils, but I battled to find much information with plant analysis. And then I sort of realized that what I need to rather do is to rather look at analyzing what I have, but through the understanding of the plasma science and what we've been taught over the last couple of years. And so the first thing when I saw that how the method they'd used, and the method was that with a little bit of caustic solution, immediately brings me back to how we use the caustic solution to create our nano layers, and essentially opening up the layers on our copper. And from there onwards, we put it into another salt solution, which opens it up further, and we create our GANs. So the method that we had understood, that we've been taught over the last couple of years, is essentially the method that they had used a year ago by using the caustic solution, is to try and open up the plant material and see what's there, or open up the soils and see what's in there. So I had to look at these pictures that we created and try and analyze them from the plasma point of view. So when I looked at the first one, what I try and understand is, when we look at the center of our filter paper and the images that it's produced, we essentially have a stronger gravitational, weaker magnetic field in the center. And then on the very outside, we have stronger magnetical and weaker gravitational. So the center zone would show the higher maggrav strength of our different elements or minerals. The middle zone would show the proteins, vitamins, amino acids. And then the outer zone would essentially show, for me, the integrity and overall health and vitality of the plant. Another way to look at these is to look at them as different zones of similar magnetic gravitational fields. So you've got the center zone there, which is the red, and then there's a different color with the yellow, and then the blue ring showing another zone and different layers. So each one of these would be sort of different layers or zones of magnetic gravitational field strengths. And we see this in nature all the time with a cross-section of a tree trunk, and also a microscopic image of the root of an orchid plant, showing the different rings and different magnetic field strengths within the structure of that root. So that was my approach in analyzing these images. So the first one we did was our plasma radish that we had grown with the GANs, and comparing that one to the shop radish that we had purchased. Okay, so these two images, the one on the left is the shop radish, and the one on the right is the plasma radish. I will go into a bit more detail on these images. So this is just after that solution had been sitting in the caustic for 1 hour. This is just a close-up image of the shop radish there. You can just see a lot of the different layers, interactions there. And here's a close-up image of the plasma radish. And then just some other clarification of some of the markings on the filter paper is this very outer ring, sort of the gray line there. This indicates where the silver nitrate solution had wicked to, so we ignore that in our analysis. The area then, sort of the lighter brown area on the filter paper, is where that's the color the silver nitrate goes just with a normal exposure to the light. And then we start getting the darker ring. This is the outer edge of the plant solution. So it's only from that edge inwards is what we really start analyzing. So when I look at analyzing, I'm looking at the shop radish, which is on the left, and I just put the plasma radish as a visual comparison between the two. So when we look at the shop radish, we can see that we've got that sort of central white zone. We have got a blue circle there. And then we're followed by another bigger zone with a lot of sort of the forked patterns. And these forks seem to be penetrating another layer, which is sort of a lighter brown. And to me, it's sort of showing the sort of gravitational magnetic field interplay between these two areas, how that whiter creamy zone with the forks is sort of interacting with the lighter brown area. Then we have a third zone, which is sort of the bigger blue circle. It's the darker brown. As I said, you can see that these white forks, their magnetic field strength is interacting with the field strength of sort of the brown areas. So we get an interplay there. And then we get the real outer edge where we sort of reach a balance point. So those are sort of the pictures that one can pick up from the shop radish. And then all I've done here is the reverse. So I analyze the plasma on the left, and I'm just showing the shop radish for visual comparison. So on the plasma radish, we have it's overall a very different picture. One would assume that they are not of the same plant variety when we analyze them. But here again, on the plasma radish, in the real inner zone there, we have the white zone. And then the next zone, which is sort of the next blue circle there, there we get the same white-brown mix, but it's formed its own sort of unique zone. Now, when we compare that white-brown mix to the shop radish on the white, we can see that this is that white sort of brown zone has extended quite far into the outer edges of the shop radish there, and intermixing with sort of the brown and orange layers. Whereas on the plasma radish, it's maintained its very strong, small, and maintained its structure. Then we get different patterns coming in from that next zone. To me, they're very well defined, holding their shape, and also interacting into the light orange and the red zones there. And then we have really clearly distinct sort of orange and red zones. And then the outer boundaries is also very well defined. And it also shows sort of an inner and outer zone on that boundary. So we have a very different pattern and structure that's created between the plasma radish and just a normal radish. What we sort of observe is that we have a lot more distinct layers, really defined layers on the plasma radish, which for me indicates stronger areas of field strength. Both solutions were soaked in that weak caustic environment. And to me, the various components on the shop radish seem to have been broken down, or as they opened up gravitationally magnetically very quickly in that caustic environment, where we can see where that mixed white-brown area has really spread out to the outer edges of that zone, whereas the plasma radish, it's maintained itself still in the center. And by doing that, we're seeing more and more different layers. And that outer boundary on the plasma radish is really, really distinct and defined, to me indicating a very strong gravitational magnetic field of the plant as a whole, and may give an indication as well as to our longer shelf life. So that was the radish with the GANS against the shop radish. And then I did a one for the radish, which was just grown in our environment. So we never added any plasma to this one. It was just grown amongst other plants where we had added the GANS. And they grew about 1.5 meters away from the other plants. And so there again, we can see the chroma of the plasma radish, that environment radish. There's close-up again of lots of different layers. And here I've compared the three. So we have on the left, the plasma, the middle is the environment, and the third one being the shop. So when we look at the border area, we can see it's really, really distinct on the plasma. It is there on the environment radish, not as strong. And then on the shop radish, we only seem to have sort of the one outer band there. And then that white structure where we had seen very distinct in the middle for the plasma radish, the environment radish seems to have opened up a bit more. And then on the shop radish, it's really, really opened up. And so to me, it's showing how the plasma radish seems to, the plant seems to retain its integrity, even in that caustic environment, whereas the radish from the shop, if the structure of the plant is so weak, then that weak caustic solution has opened it up very, very quickly. So when I look at those three pictures, the plasma radish seems to sort of show very well-defined patterns, sort of high integrity, high strength, and vitality. Then I did the same thing with a lettuce. I thought try some other plant. So our lettuce is also grown with a plasma, and again I had to buy another lettuce from the shop. The lettuce, we treat our seeds differently in that because they're so small, we don't really soak them in. It's very difficult to soak them in water and then plant them. So we just plant our seeds normally, but during the 4-week period where they are on our grow table, we water them with the GANS while they are still starting to germinate, and throughout the growth period, we then add the GANS during that period of their growth. And you can see there's the chromos. The one on the left is the shop, and the one on the right is the GANS cost lettuce. Again, very, very distinct and unique images produced. There's a close-up of the different bands. And again, we're seeing the forked effect and the interaction of the different layers there. Whereas on this COS lettuce, we have very defined boundaries like we've seen on the COS. So when I'm analyzing the shop lettuce, and then we just got the plasma to show, again, we see the inner zone, and then the next zone, sort of the white area extending into the orange layers. And then we have sort of the red area followed by the brown, creating the outer boundary. When I look at the plasma lettuce, we can see quite a few distinct layers. We have the center zone, and then we get a lighter brown. That's with that first red arrow, small arrow, and then we get the edge of the white zone. And then they say that white area is very well contained by the next lighter brown area. And we don't see any penetration into that next field strength layer, as we saw on the shop lettuce. And it's a very wide band. And then we also have a very well-defined boundary on that COS. So that was where we had just left the plant solution in the caustic with 1 hour. So I wanted to see what would be, if there would be any changes if we had left the plant solution longer. So I had left those solutions for 3 days. So sitting in the caustic environment, and I did some more chromos. And now we can see on the left is the shop, and then on the right is the plasma COS. So what we've, I think, yeah, there we go there. This is the, when I look at the evaluation, the shop COS lettuce. So the one on the left is the 1 hour, and the one on the right is 3 days. So to me, they're almost the same. Very little difference between the 1 hour and 3 day, which tells me that the maggraph field strength of the plant structure was initially weak. So that caustic environment was able to weaken those bondings in that first hour, because there's very little change after the 3 day effect. But when we look at the plasma lettuce of the 1 hour on the left and the 3 days, we start seeing some differences. What we're seeing is when you look at this brown, very wide brown band on the plasma COS on the 1 hour, this has seemed to be opened up after 3 days, because we're starting to see a lot more detail, a lot more structure in there, a little more layers. So again, that's telling me that this extra time allowing the layers to separate more, so that caustic environment was able to open up a little more of the layers so that we could see. But we see the difference between 1 hour and 3 days. So again, it's showing me after 1 hour, really strong integrity of the plant material. And then even after 3 days, the structure has opened up a little bit more, but still maintaining its strong integrity. So it's showing to me the very strong gravitational field strengths of all those components within the lettuce. So there's just a bit of analysis on the 3 day one. You can see that the area on the left, which is the plasma COS, there's a very strong band, circular band there. Now this circular band is essentially what we've seen on the shop lettuce after 3 days, how it's opened up, very weak structure, so it can move into the next layers of strength. And then we see here as well on the COS lettuce after 3 days, we've seen essentially how that the band on the right, the 1 hour, we don't see a lot of detail on the brown, but on the 3 days, we start seeing some more detail, different layers, interactions there. So again, that structure has opened up after the 3 days. And when you look at the outer bands there on the shop COS lettuce on the left, very little definition there. And then on the plasma, again, we've seen very strong outer boundary for that plant. So when we look at the two, to me, it's I can see the integrity and the strength of the produce grown with the plasma. The magnetic gravitational field strengths of the cells, the amino acids, and the proteins remain intact and are not opened up by that weaker caustic solution. Whereas on any of the shop produce that we've seen, how that the structure had opened up very, very quickly. And we see a lot more detail as we open them up. So when I look at the overall analysis, there's the one on the left is the plasma radish, and the one on the right is the plasma cos. So you see very well defined patterns, structures, a lot of detail of layer, a very strong outer boundary, which to me indicates a very strong, healthy, and vitality of the plant. The plants have a stronger gravitational magnetic field strength, which may account for the higher nutrition and the shelf life that we always see in the produce. As I say, these pictures show a very nice uniform structure and order. To me, these pictures may also indicate the emotional state of the plant, as in the work done by Masaru Emoto, when he freezes water, showing the different crystalline formations of a person's emotion that is reflected into those ice crystals. Maybe the chroma images are giving us a glimpse into the emotional state of the plant world. You know, are we growing emotionally balanced plants using the GANs, and this emotional balance creates plants with higher nutritional levels? The plants are happy to give and be the best that they can be. You know, further study will be needed to sort of identify and analyze what the different layers are actually, such as what minerals or proteins or amino acids they are reflecting. This work, as I say, is my interpretation using the principles and understanding of plasma science technology. And it may or may not lead to further work in this direction. The images of the produce grown with the GANs certainly tell a story. How we interpret that story maybe needs some more work. And just to end off, what we'd also seen in keeping our jars of the plant material for a couple of days and sometimes weeks, is we've noticed quite a distinct difference. The two bottles, one on the left is the shop radish, and the one on the right is our environment radish, and it was the same for the plasma radish. Now we can see in the bottle on the right being environment radish and the plasma radish, all our plant material had settled to the bottom, and we had this green color on top, and there's no smell from it even weeks later. But the shop radish, you can see we've got a very distinct, all the plant material had floated to the top, not sunk to the bottom, again showing a much weaker structure. And this started growing mold, and when you opened up the bottle, the smell from this was rather putrid. And this to me also just showed an indication of the noticeable differences between the produce grown with the plasma and that without. So I hope you enjoyed that, and I'm sure you can tell us whether this belongs on a scrap heap or we try again, Mr. Keshe. Thank you.
Very good. Thank you, Jim. Are you there, Mr. Keshe?
Yes, I'm listening. I took some pictures of this. It's very nice. It is, can you hear me?
Yes, we can.
Yeah. We expect a lot of things, why and how things change is because we change the field areas outside. So we change the cache comes because we have changed the environment in this area. And that in turn has created a new dimension of positioning within the structure of the cells. There is a picture which I took while Jim was going through it. If there's anybody else asking any questions, please go ahead. Do you have any other questions with you?
Well, I had something to show that's related to this. Perhaps I can insert that. You want to look for a picture in the background for a minute.
Yeah, no, it's Jim, can you go back up on your pictures to the green one? Go back up to the green. More. A little bit more. More. I think it's just a couple of pictures. Yeah. Further up. The green picture, there's one picture which is green color.
Oh, that one?
Yeah, that's the one, yeah. Just 1 second, please. If you look at the structure here, what we call a honeycomb, and if you look at this structure, it's all the way through the same. If you look at the structure of the skin of the man, is the same. If you look at the structure of the kidney, is the same. And what these shapes mean, and when you introduce ganses outside, you change the dimension of these shapes. Means you change the dimension, the size of the magnetic gravitational fields in these. Where we see the body, the structure, the physical structure, is where the magnetic gravitational field has changed to the matter state. And you see, for example, in one place, they have a uniform shape. You can see it here in this band. These spaces, these what you call hollow spaces, in them is not hollow, is the gravitational magnetic fields, which this, for example, if I can change it to a different color, this here dictates the size of this and dictates what this can bring in, and then this bracket here decides what needs to be filtered to go further in. And then you see again another filter band here at the point of every change. We see uniformity in the size. We look at the structure as honeycomb, but in fact the empty space is where the plasma sits. The pressure that plasma can accept allows physicality in its boundary. and we see the boundary of the cell. And this is how we look, more or less. A lot of them are hexagonal or follow near enough that shape, where the balances are in a 6-field dimension, which in the science of man we do not understand yet. Because we are looking at a cross section. There is another half to this on the other side which has been cut. So this is like those magnets which we put together on the floor, the ring magnets. This is exactly the same thing. But because it's hexagonal, it creates different conditions. This is in one of my lectures, private lectures years ago. I explained this, that if mankind, if us ever produce hexagonal magnets, like the way it happens in the universe, as now we learn the ring magnets, we will see a new dimension in the science of man. We will understand a new concept in technology, very much reality in the dimension of the plasma. When we look at a plasma as a circle, this is the whole structure of the system. As a ring. But if we position enough magnets, we will see hexagonal combination. If you leave them to find their own position. But if we ever manage to create a hexagonal magnet, we will see the operation of the plasma in a physical dimension. And teaching of science, conversion from plasma to fields to matter, as I call. You have a plasma, you have a field, and then you have the matter state. Then we will understand this. Then we become more in a dimension of reality, and we can see how cells perform. And in a way, if we ever manage to make a hexagonal 3-dimension magnets, then we will see a different field difference. And collectively, then we can understand how the body of the man works, how the body of the live entities work. And this is if you take a cross-section of every living entity, you observe this condition. And depending how compact they are and how they are closer to the center, the shape becomes more regular, more what you call homogeneous in size. And they usually become homogeneous at the point of change. And when you introduce plasmatic magnetic field, then the whole ball game changes. And it's fantastic to see this, because you take any cross-section of any tissue, you will see this. So we always look at the boundary of this, but in fact we have to look at the plasma inside it. The field strength inside it, which creates that push, creates that boundary. And that field, at a point of interaction with other field, at a point of balance, they create a matter state. So if you look at it this way, I try to clean up my mess a little bit, that you can see better. Oh my God, the rubber is very good. Okay. So what I'm trying to explain is when we look at the boundary here is when the gravitational magnetic field from center of this and center of this have come to reduce from field to matter state, have created that. These are what we call in the science of plasma, subplasma levels. This is all made up. These space gaps just don't create as a space. These are all plasma fields which create, and the condition of what they allow to cross them in the space gap. Here you see them next to each other, but there is a space gap. In that space gap, the energy can come to here. And this could be of a different strength. And at this level, by absorbing all the fields here, then there is a space gap here. What can go through? In a scientific language, we call this one frequency. But here is plasmatic frequency, if you call it plasmatic energy, that it can get through. And what is created here in reaction and in condition to this side, it creates the size of the cell. But when you see the size of the cell, this cell has a center of energy. It's there, sits there. It's the soul of it. And what it radiates in balance in interaction with others creates the matter state. This is on its own, even this partition has life. Because it has to hold on to and get connected to the next. If one day mankind go further in depth and we have machines to do it, you see this is a living thing. This here follows the same structure of field. And then this we
We've lost your audio, Mr. Keshe. We see a line that you're making. Still not hearing you. Still not able to hear Mr. Keshe.
Can you hear me?
Yes,
Hello?
now we do.
You can hear me, okay. It's very strange how this thing happens. I can hear you, but you cannot hear me. This says upload or download, which is weak. Okay. Hello?
Yes, now you're clear.
Now I'm clear, okay. Now I'll switch to another one. So we see this structure even in the universe, but in a larger dimension. You see this structure in galaxies.
Mr. Keshe, oh, sorry, go ahead.
Yeah, it's just that If we look at the structure of the universe, we see the same. If you look at the structure of the planetary system, we see the same. In the universal dimension, we still see hexagonals between the galaxies, position of the galaxies, and position of the field environments, which we are not aware of. We haven't got the technology to observe yet. And interesting enough, in time, when we understand this, in certain points in the universe, we can colonize. We can live, because dimension of physicality at certain strength is at the balance fields of the physical life of the man. And it's very interesting to see this, because it's a repetition of the same structure, the same process, and one way or another, life, as we call magnetic field balance, repeats itself, because it cannot be any different.